Hi guys, so they want us to find the moment of inertia for this particular ship, and they're telling you that the moment of inertia is through the center of gravity, wheresoever that point be. We'll have to find it. It's very important that we find it. So first of all, let's find the center of gravity so we know exactly the section in which our moment of inertia is placed. To find center of gravity for this object, since we know the object is symmetrical, we know that the in the x-axis it will always be on this point. We just simply need to find the vertical height of it, which is the y-axis of the center of gravity. So it will be y-axis of center of gravity is equals to the area of the first shape times its centroid plus the area of the second shape times its centroid from the reference of axis plus its third one all over the total area a1 plus a2 plus a3. So now we simply just need to start finding all of this. We're going to start with this top rectangle here. A1 is going to be equals to 60 times 20, which is equals to 1200 millimeters square. So Y1 is going to be equals to this point from its centroid down to the reference of axis, which is at this point. So that will be 20 divided by 2, which is from here to here, plus 100 this point, plus 20 this point. That will be equals to 130 millimeter. Next for A2, that's a middle rectangle. The area is simply 100 times 20, which is equals to 2000 millimeter square. Its centroid, that's its center, is its center to the reference line. That will be 100 divided by 2 plus 20. That will be equals to 70 mm. And lastly, for the last shape, we're going to have A3 and Y3. It's going to be equals to 20 times 100, which is 2000 millimeter square. And for the y, it's simply the centroid to the base. That would just be 20 divided by 2, which is equals to 10 millimeter. So we simply put this back into the formula, just impute it into your calculator, and you're going to get that y is equals to 60.8 millimeter. Now that we know the point where the moment of inertia is, we begin to calculate for moment of inertia. What you actually have to do again is that you still break the figure into its components, that is top rectangle, center, and the bottom rectangle. Starting from the top rectangle, we're going to solve for its inertia. We'll call it I bar xx. Now for this particular question, I'm only going to be solving for moment of inertia in the x direction because the question specifically asks us to find the moment of initial section about the horizontal axis. Now, you have to understand something. The object contributes its own inertia, and then the inertia it will have when it's rotated from the center of gravity. Let me explain that. So, if this is the point where you want to rotate something out, and there's a mass at this point, and you want to rotate it like this, you see, the mass itself is going to contribute its own inertia, and then at this point that you want to turn it around, it is also going to produce an inertia, which will be, if this is r, to be denoted as a r square. But if the object was at the pivot point, the only inertia that will be needed is simply just the inertia of the object itself. I'm explaining this concept because we're going to be using this a lot here. The inertia of the rectangle itself is given as bd cube over 12. This is a proven formula. You can go and solve it online. You can go and check how to derive it. Plus the inertia it will give when it's spun from that center of gravity. So from this point to its own center, that would be the area of the shape, which is 60 times the area of the shape times that radius or height as you please, which will be, to get this, we know that from the center of gravity down it is 60.8 as we got before, and we know that from this center down it is 130 mm. So to get from here to here, we simply just do 130 minus 60.8, which is going to give us, so just going to write that there, 130 minus 60.8 square. It's going to be equals to The breadth of this particular shape is 60. The distance or the height is 20 raised by 3 over 12. The area is 60 times 12, which should be 1200 times 4788.64. There'll be plus here. And you solve this, you're simply going to get that the inertia for this particular shape will be 5786 times 10 raised by 3 millimeter 4. Now let's move on to the center rectangle. Now for the center rectangle, now we're moving on to the center rectangle, which is at this point. You know that the moment of inertia line is somewhere along here, 60.8 away. So to find for the, I'm going to call it I bar bar x, this is the inertia in the x-axis. It's going to contribute its own inertia because this is the moment, this is the center of gravity for the entire object. This is the moment of inertia reference line, 60.8, and this is the center of gravity for the actual rectangle itself. Therefore, there's a kind of offset. So because of that offset, it's going to contribute its own inertia, and then the inertia is going to produce when it's rotated from the center point. So its own inertia is going to be BD cube over 12, because the inertia for a rectangle, that's the formula, plus the area. The area is simply going to be 100 times 20, which is 2000, times the offset or the radius from this point to this point is simply going to be from here to here. We know it's 100 divided by 2 plus 20. That was, we got 70 mm. It's going to be 70 mm. It's going to be 70 minus 60.8 square. We know that B is 20. We know that D is 100 raised per cube. If we resolve all of this, simplify the equation to get the answer as 1836 times 10 raised by 3 millimeter 4. Next, for the last rectangle, that is the bottom rectangle, which is also going to contribute its own inertia as well as the inertia if you try to rotate it from the moment of inertial reference line, that's at this point. So its own inertia is BD cube over 12. We know B is 100. We know that D is 20 raised power 3, plus the area is simply 2000 again, times, I'm going to just erase it so we can get a clearer view. The center of the moment of inertial reference line somewhere along here is 60.8. Its center of gravity is from this point to this point, which is 10. Now we need to know the length of the radius from this point to this point. This is a r square. This r. So it's going to simply be 60.8 minus from this point to this point is 10. So 60.8 minus 10 square equals to, if you solve all of this, you're going to get 5228 times 10 raised by 3 mm4. Next, to simply get the total moment of inertia in the x-axis, we're going to just add everything up. That's I bar xx plus I bar xx plus I bar xx. Simply going to be 12,850 times 10 raised by 3 mm4. That's just the final answer. I hope you understood. Anything you don't understand, please do not hesitate to ask in the comment section. Thank you.